This is a code walkthrough for the example file LoopingWhileTypeUnsafe.java. This is a very short, simple file which demonstrates the problem of type-unsafe input. In this file, we're simply setting up a scanner to read some user input. We're putting out a prompt and asking the user for their age, reading the age, and then echoing it back out. Now, implicit in this, and it's not really stated in the prompt though, is that we're expecting the user to enter their age as an int because that's what the scanner object is expecting to read with this next int method. As long as the user enters the expected int, everything's going to be fine. Let's see what happens when that's not the case though. So as always, we'll start by compiling this file. Then let's set a breakpoint on main and we'll single step through this with the debugger. We'll set up our scanner, issue our prompt, and read that first age. Let's say for grins 21, as in the lecture material. Put an enter, and we read that, and we echo it out, and the program's done. No problems. Let's run this again with a different value for that age though. We're expecting to read an int, but let's do something a little different. This to us is still 21, right? 21.0. It's just a very precise 21. But look what happens now when we try to read this with next int. Oh, we need to acknowledge this and enter that. Boom, an input mismatch exception. We're expecting to read an int value, but we entered a floating point instead. Not going to work. Let's run this again. Actually, I'm going to take the breakpoint off now and simply free run this a couple times. Let's say we're a little kid, and to little kids those half years really matter. So let's say we ask our little niece or nephew how old they are and they say they're 5.5. We put that in. Same thing. We expected to read an int, but we got something which is more appropriately a float or a double. Let's run this one more time, and suppose we're asking our elderly, very literate aunt how old they are, and they'll say something like 85. They'll spell it out. What happens now? Same thing for a different reason. We expected to read an int, but we got something that's a string instead. So this is the type safe problem. As soon as we open up the possibility for the user to enter data, we also permit the possibility of the wrong kind of data being entered. And this is the type safe problem. Or perhaps more precisely, perhaps I should say the type safe situation, but the type unsafe problem.